Hey guys, good afternoon to everyone. Today we are going to solve one of the most important trigonometric questions which are most frequently asked in CBSE board examinations. And most of the students are stuck in these type of questions, the to prove questions. So this is our first question. So in this question we have on the left hand side cot to the power 4 theta minus 1, and now we all know, we have studied in our childhood as well, that is in the previous classes. We have read about the algebraic expressions, right? That a square minus b square equals a minus b multiplied with a plus b. Similarly, we are going to use this expression along with the trigonometric properties and the trigonometric formulas, as we all know. All right. So here we have cot to the power 4 theta, which can be written as cot square theta whole square minus 1, right? When 1 can be written as 1 square. Similarly, by using the above formula, we can write this whole term as assuming cot square theta as A and assuming B as 1 as B, we can write it further as cot square theta minus 1 multiplied with cot square theta plus 1, right? This is the formula that I'm talking about, which I have made a square, or you might say highlighted around. Now we all know about the formulas, right? That cot square theta plus 1 equals cosec square theta. But even though you do not remember, or many people, what happens to many students is that they might forget or might be doubting themselves only. That is, they might not remember the formulas correctly, or might get messed up because of the huge, there are so many formulas, right? So instead of it, you just remember this method. All right, I use this trick often when I could not recall the correct formulas during the examinations, right? Then I used to draw this triangle, that is 3 4 5. Always remember this. uh, for example, assume 3 4 as the base or the perpendicular, which one as you want, and 5 as the hypotenuse. Now we know that cot theta is the reverse of tan theta, that is base upon perpendicular is cot theta, that is 3 upon 4, right? So, and here we have to find out the formula for cot square theta plus 1. So squaring this, we get 9 upon 16, that is cot square theta equals 9 upon 16. Now adding 1 to it, we get 25 upon 16. But we all know that 25 upon 16 is nothing but 5 upon 4 whole square. Now, in this triangle, what is 5 upon 4? Even though you know, don't remember, always, now we all know that 4 upon 5 is nothing but sine theta, right? So 5 upon 4 is nothing but cosec theta. So 5 upon 4 whole square is cosec square theta, right? So this is how you are required to recall the formulas if you have any doubt in the formulas that are there in the question that are to be used. All right. So moving on, we are going to apply this formula, this identity in this in our LHS. All right. So our LHS can be further simplified as we can write cot square theta minus 1 as it is. All right. And then we can write cot square theta plus 1 as cosec square theta. What I am saying is that this term can be written as cosec square theta. All right. So putting it in our equation, now we know that uh, that is cot square theta plus 1 is equal to cosec square theta, right? So that is what I am about to write. Cot square theta plus 1 equals cosec square theta. Now if we just put cot square theta on one side of the equation and take the plus 1 on the other side and put there minus 1, that is cosec square theta minus 1. Now we are going to use this equation. Now let LHS be equation 1 and this be equation 2. Now by applying this equation, that is equation 2 and equation 1, we get, that is LHS equals cosec square theta minus 1. That is we are replacing cos square theta by cosec square theta minus 1, and then there is the extra minus 1 that we write here. Alright, and then we keep the cosec square theta as it is. And now I hope that you don't have any doubts. And then we multiply this cosec square theta with the cosec square theta on the other side. We get cosec to the power 4 theta. And then similarly, here on the other side, we have minus 1 and minus 1, that is minus 2, right? Multiplying it, we get minus 2 cosec square theta. But if you look closely, in the given question, we have cosec square theta minus 2 cosec square theta. But shouldn't it be rather be minus cosec square theta instead of writing it separately cosec square theta minus 2 cosec square theta? So we all know that we all can see clearly that there is a typing error over here, and don't worry about it too much. All right, even in CBSE board examinations, typing error happens. All right, here it won't be cosec square theta minus 2 cosec square theta. It rather be cosec to the power 4 theta minus 2 cosec square theta. All right, moving on. So in this next question, we have sine to the power 4 theta minus cos to the power 4 theta equals sine square theta minus cos square theta equals 2 sine square theta minus 1 equals 1 minus 2 cos square theta. We have to prove this, in which there are, you know, there are not only LHS and RHS, there are four uh, identities or four expressions, four trigonometric expressions are there that have to be equated to each other. So such questions may appear a bit tough to you, but always remember that start with the LHS and then move on to the next term after it, and then gradually keep on moving from one term to the another term. That is, break down the bigger problem into smaller ones. So in the LHS, we have sine to the power 4 theta minus cos to the power 4 theta, right? Now, we all know from the previous, in the previous one also we did the same thing, that a square minus b square equals a minus b multiplied by a plus b, right? So applying this, we have LHS equal to sine square theta, that is sine to the power 4 theta minus cos to the power 4 theta, which can be further written as sine square theta whole square minus cos square theta whole square, right? Now, next we can simplify it as a minus b multiplied by a plus b, that is sine square theta minus cos square theta multiplied with sine square theta plus cos square theta. Now we all know this property, right? That sine square theta plus cos square theta is always equal to 1. So applying it, we can just cancel it out. That is, we can forget this term even existed, right? We can write LHS as sine square theta minus cos square theta. And as you can see, this is what is needed in the first to prove section. That is, this term equates this term, right? Now we have to move on to the next term, that is 2 sine square theta minus 1. Now let me just simplify it for you. All right. We know that sine square theta plus cos square theta equals 1, right? That is what we saw in the previous. Now we need only sine square theta, that is equal to 1 minus cos square theta. Now let it be equation 1. And the next we have, similarly, taking sine square theta to the right hand side, we have cos square theta equals 1 minus sine square theta. That is the second equation. All right. Now clearly, in the above term that we have to prove, that is 2 sine square theta minus 1, you know. And here we don't have any cos theta terms, right? We don't need the cos theta terms. So we have to convert the cos theta terms, that is the cos square theta. We have to use this identity, that is the second equation one, right? In order to convert it into sine terms. All right, let LHS1 be equation 1 and this be 2 and this be 3. All right. And now putting equation not 1, rather it be 2, that is equation 2 in 1, we get, that is sine square theta minus cos square theta equals 1. I'm sorry, it should be not equation 1, it should be equation 3. All right. So sine square theta minus cos square theta is going to be equal to sine square theta, as we have to keep the sine term, right, minus 1 minus sine square theta, that can be written instead of cos square theta. Now this can be further written as sine square theta minus 1 and minus into minus, that is opening the bracket, we get plus sine square theta, which is equals to 2 sine square theta minus 1. Henceforth the next expression has also been proved. All right. So similarly, putting the next equation, that is equation number 2 in the first equation, that is the LHS, we get sine square theta minus cos square theta equals, now we need only the cosine theta terms. All right. So we have to remove the sine terms. Henceforth, we can write it as 1 minus cos square theta minus cos square theta. Now it can be written obviously as 1 minus, there are 2 minus cos square theta, henceforth it can be written as 1 minus 2 cos square theta. Henceforth the next expression has also been proven. Now moving on to the next question, we have LHS equals sine square theta upon cos square theta plus cos square theta upon sine square theta equals 1 upon sine square theta multiplied by cos square theta minus 2. Now many of you might be thinking that uh, numerators and denominators in trigonometry, it might be new to you. All right. So no need to panic. You just remember what you did in case of fractions, right? You just took out the LCM and then multiplied them, right? Same, we have to do it here as well. All right. Now you can clearly see that in the right hand side, the denominator is sine square theta multiplied by cos square theta, which is the LCM of sine square theta and cos square theta. But where did the minus 2 come out from, which doesn't have any numerator and denominator? Henceforth, it might be occurring to you that that clearly means that there are cancellations that are ought to happen in this question. Now multiplying it after taking the LCM, we have sine to the power 4 theta plus cos to the power 4 theta upon sine square theta plus that is multiplied by cos square theta. Now whenever you see sine theta and cos theta, it should always struck on your mind that every time we are ought to use the property of that sine square theta plus cos square theta equals 1. Now here we have sine to the power 4 theta plus cos to the power 4 theta. Now how can we reach to that equation sine square theta plus cos square theta? Here we can see that uh, we know that that is a square plus b square, right? The algebraic expression that we are all aware about, plus 2ab is equal to a plus b whole square. Now why did I write this side, whereas regularly we write a plus b whole square equals to a square b square plus 2ab? We wrote it because here we have sine to the power 4 theta plus cos to the power 4 theta, which we are about to treat as a square plus b square, right? So using this equation, we get LHS equal to, that is the sine to the power 4 theta term can be treated as a square, that is it can be written as sine square theta whole square plus cos square theta whole square. We are writing the to the power 4 terms as square of the square. Alright, denominator is as it is because we need it. Alright, so here we can clearly see that the formula can be implemented over here, the above algebraic formula. Alright, so we have sine square theta plus cos square theta. Why do we get it? Because we are treating them as a and b, right? So we get this whole square minus 2ab. Now a and b are sine square theta and cos square theta respectively. Putting it, we get minus 2 sine square theta multiplied with cos square theta divided by sine square theta cos square theta. Alright, now it is quite much easier for you, right? Now we know that uh, sine square theta plus cos square theta is equal to 1. Again, the same formula that we have to use almost every time. Putting it, we get 1 square, that is obviously 1, right? 1 minus 2 sine square theta multiplied with cos square theta upon sine square theta multiplied with cos square theta. Now clearly you can see that 1 upon sine square theta cos square theta can be written separately, and the minus 2 sine square theta cos square theta term upon sine square theta cos square theta term can be written separately, and by cancelling the terms out in the second expression we get LHS equal to 1 upon sine square theta multiplied with cos square theta minus 2, that is equal to RHS. Hence we have proved that LHS equal to RHS. Alright, hence proved. Moving on to the next question, here we have LHS equal to cos to the power 4 theta minus cos square theta, and we have to prove it as equal to sine to the power 4 theta minus sine square theta. Now we know that that is sine square theta plus cos square theta, again the same expression, that is equal to 1. Now we can simplify it as cos square theta equal to 1 minus sine square theta. Now why are we doing this? We are doing this because we want to put cos square theta equals 1 minus sine square theta in order to get only the sine theta terms, so that there are no other cos theta terms remaining on our expression, right? Putting it, we get, that is we are separating the cos square theta terms. Henceforth we have written cos to the power 4 as square of the square. Now again we have written it as 1 minus sine square theta whole square minus in bracket 1 minus sine square theta, which can be further now squaring the, that is there is a whole square on that term, right? So we are using the same formula, a plus b whole square or a minus b whole square, 1 plus sine to the power 4 theta, and this is a and b, and the other term is minus 2ab, that is minus 2 sine square theta. Now we have on the other side we have a minus in bracket 1 minus sine square theta. Now we are going to open the brackets and we get 1 plus sine to the power 4 theta minus 2 sine square theta, and then minus of 1, and then minus of minus sine square theta, that is plus sine square theta. Now as you can clearly see that plus 1 and minus 1 here we have get cancelled out, and here we have minus 2 sine square theta and plus sine square theta, overall giving us sine to the power 4 theta minus sine square theta. That is same as the RHS that we are supposed to prove. Now in this next question we have LHS equal to sec theta plus tan theta minus 1 multiplied with sec theta minus tan theta plus 1, right? So I'm writing it in brackets so that it becomes much easier in order to understand these steps as well. All right, So writing in bracket, we can take out minus as common, right? In such questions where there is plus and minus, as you can see, and on the other side there is minus and plus. Therefore, if we take minus as common, then clearly it takes the same symbol as on the other side, right? That is tan theta minus 1 can be taken out common, in that is inside the bracket. Now further simplifying it, we can see clearly that assuming this is a, b, and this one as a as b, we get a plus b multiplied with a minus b, and we already know that a plus b multiplied with a minus b is same as a square minus b square, that is sec square theta minus tan theta minus 1 whole square, as we are assuming these two terms as a and b, henceforth that is a square minus b square. Now further simplifying it, as we guys have seen above that cot square theta plus 1 equals cosec square theta. Similarly in this case also their reverses, that is tan square theta plus 1 equals sec square theta. Henceforth, sec square theta can be further written as 1 plus tan square theta. Now, why are we doing this? Because we need the RHS in terms of tan theta only. Henceforth, and then this tan theta minus 1 whole square can be further simplified as 1 plus tan square theta minus 2 tan theta a minus b whole square, standard formula. 1 plus tan square theta remains as it is, and the other term can be taken out of the bracket. Plus becomes minus, minus becomes plus, as you all know, and this 1 minus 1 tan square theta minus tan square theta gets cancelled out. We get only 2 tan theta remaining, that is equal to RHS, hence proof. In the next question we have on the LHS side, equal to 1 plus tan square theta, uh, sorry, not theta, it is a, and plus 1 plus 1 upon tan square a, which can be, if you see clearly, then we can clearly see that 1 plus tan square a is always equal to sec square a, right? We know the standard formula. Henceforth, we are going to use the standard formula instead of breaking down tan a into sine a upon cos a and then simplifying it step wise. It would become a huge, it would become a huge question then. It would become quite messier. And then if we make any mistakes, it would be very hard to see on which part we have done the mistake. So rather, we can simply use these standard formulas. That is 1 plus tan square a equals sec square a, right? That is 1 plus tan square a equals sec square a, not theta. But let me also tell you that if you write theta, then marks would be reduced if there is a in the question and you write theta. Alright, so beware. And also 1 upon tan square a equals cot square a. So LHS equal to, that is sec square a plus, now we know that 1 plus cot square a is obviously equal to cosec square a, right? So we can write it as 1 plus cot square a, that is 1 plus 1 upon tan square a, can be written as 1 plus cot square a, that is equal to sec square a plus cosec square a. Alright, now we can simplify it into sine and cos as we are on the last stage. Now it is written as equal to 1 upon cos square a, that is sec square a. Alright, and then cosec square a can be written as plus 1 upon sine square a. Now similarly, taking out the LCM, we can clearly take out the LCM and then write it down as sine square a plus cos square a upon sine square a multiplied with cos square a. Alright, but in the RHS side, we see that on the top there is 1, right? So we have achieved that part. That numerator part has been equated. That is sine square a plus cos square a equals to 1. We all know that. and the denominator part contains only sine a terms. There is no cosine a terms, so we need to write sine square a will remain as it is, and then cos square a will be written as 1 minus sine square a. Now you can clearly see that we are reaching to the RHS side, right? Henceforth it equates to 1 upon sine square a minus sine to the power 4a. And also you can write down the identities that are that you are using in each step. Henceforth, this term, that is LHS term, can be equated as sine square a minus sine to the power 4a would be in the denominator, right? Now, that is by multiplying these terms, we are getting this, all right? Sine to the power 4a is also there, and the numerator is also matching, that is equal to the RHS, hence proved. So thank you for watching this video, and I request all of you guys to like, share, comment and subscribe to my channel, and also write down if you do have any doubts related to the questions that I solved in this video, or any other doubts that you want me to include in the future upcoming videos. Thank you.